All right, for practicing naming, we're going to start with looking at if you're dealing with ionic, covalent, or if you're dealing with an acid. So anytime there's a metal, like lead, he's a transition metal. Anytime you deal with a metal, you're doing the ionic naming that we've been doing since before Christmas. So your first substance is going to become Pb, okay? And it tells you that it's lead 4, so that means he's a positive 4. And I'm not going to make this superscript, you know what it is, okay? Chromy is CrO4, and that's a negative 2. So if we take a look at how these two are going to combine, since it's ionic, lead's going to give 4, chromate's going to take 2. So the closest number those two superscripts have in common is 4. So lead is already there, so it just becomes CrO4 2, because it takes 2 of this to match up, okay? And like I said, this is actually a subscript, but for time's sake on the video, I'm not going to go through and do that for every one of them, okay? All right, second problem, I gave you the formula, or the name, sorry, and you're going to give me formula. And so diphosphorus pentoxide, whenever we see mono, di, tri, tetra, penta, we know we're dealing with covalent bonds. We're dealing with something molecular. So you just do what it tells you. Diphosphorus, so that's P2, and pentoxide is 5, so it's O5. P2O5 is the chemical formula for this, okay? Hydroiodic acid. Anytime you're dealing with acids, they're going to start with H's, and this is what you looked at yesterday in your reading. So if it has the prefix hydro, that means we're dealing with just an element. So our two elements are hydrogen, which is a positive one, and iodic is going to be iodine, which is a negative one. So the two of them come together. Positive one, negative one, balances out, so it's just HI. All right, our next one's a little bit tricky here. We are looking at 3 capital letters, so you know you've got a polyatomic in there. So our first substance is potassium. Now our second substance, if you look in your periodic table, you have an option of permanganate and manganate. And the difference between the two is permanganate has a -1 charge and manganate has a -2 charge. So if we take a look, this 2 on potassium had to come from the anion. So this is actually potassium manganate. You don't do Roman numerals on the anions, but this is the only time that you have to pay attention to which anion was used. Okay. All right, our next one, HBr. So you know you're dealing with an acid because the first element is an H. Okay, so we notice we just have HBr. So whenever we only have 2, there's no polyatomics in there, no oxyacids, you just name hydro, and the bromide becomes bromic, okay, acid, hydrobromic acid. So whenever you're dealing with 2 elements, the binary in acids, you just name it hydro, and then ic goes on to whatever that second substance was. Okay, our next one, SCl6. So sulfur is a nonmetal, chlorine's a nonmetal. These are going to be covalently bonded, so this is when we use the mono-di-tri. Remember, if there's a metal at all, you're going ionic, but there is no metal here. These are both nonmetals. So we name the first substance, sulfur. Second substance, there's 6 of them, so hexachloride. All right, number 7, sulfurous acid. All right, so notice that this is ending in OUS. Okay, it's not ending in ic. Notice there is no hydro. So we know we're dealing with a polyatomic. Well, OUS's started from ites. Okay, so instead of sulfurous, this is sulfite. So hydrogen starts all acids. It's like H and a positive. Sulfite, SO3, and that's a -2. Okay, and I just found that by looking at my periodic table. So remember, ite goes to OUS, 8 goes to ic. Okay, so if I've got 1 on the hydrogen and 2 on the sulfite, I'm going to have H2SO3 for my chemical formula. Okay. Number 8, you have PBr3. So both of these, once again, are nonmetals. So we know that this is going to be a mono-di-tri naming. Okay, it's the first thing you got to look at is what am I dealing with? If there's an H, I've got an acid. If there's a metal, I'm ionic. If there's 2 nonmetals or a metalloid and a nonmetal, you're dealing with the mono-di-tri. So I name the first substance phosphorus. Next substance is tribromide. All right, CaC2O4. So notice there's more than 2 capital letters. So we got a polyatomic somewhere. So this is going to be a metal. So we name this ionically. So we've got calcium for the first substance, and C2O4 is oxalate. Nobody needs Roman numerals. We're done. Okay. Number 10. So I've given you iron 3 hydroxide. Dealing with an ionic bond here because iron's a metal. So this means Fe is a positive 3. That's what the iron 3 means. Hydroxide is a polyatomic. Okay, OH, and he's a negative 1. So the closest way these guys can come together is we need 3 hydroxides to match up to the 3 electrons that iron gave. So it's going to be Fe, OH in parentheses, 3. If we do not put that OH in parentheses, you gave me H3O. I don't want 3 of the H's, I want 3 of that entire substance. Okay? All right, our next substance here, calcium fluoride. Calcium's a metal, fluorine's a non-metal, so this is ionic. So calcium is a positive 2. He's in family 2. He's going to give 2 away as a cation. Fluorine's a halogen. That means he's got 7. He's going to take 1. Okay, he's a negative 1. So for them to come together, it's going to be CaF2 because it takes 2 of the fluorine to match up to the 2 electrons given from calcium. All right. Number 12, acetic acid. So we're dealing with an acid, so I know it starts with an H. Okay, acetic. So ic goes to 8. So there's 2 ways you'll see this on your periodic table, but this is typically the way I go with it. C2H3O2, and that's a negative 1. You can also see it as CH3COO. Both fine, can use either one that you want. Okay. Notice that you've got 1 electron being given, 1 being taken, so it's HC2H3O2 for acetic acid, which is otherwise known as vinegar. All right, our next one, H2CO3. Notice, starting with an H. So we've got an acid. So we have an oxy acid here, and by that, we're containing this oxygen. Okay, we've got our polyatomic. So I look it up, and this is carbonate. So carbonate goes, the 8 goes to ic. So this becomes carbonic acid. There's no hydro because this is not a binary. There's not just 2 substances in the acid. You are containing an oxy acid. So remember 8, so carbonate, will go to ic, and it's carbonic. I'm going to stop there and then create another video for the rest of them. If you need to go back and look and see how this is working, fine. If on the next video you want to see what you have for an answer and then listen to my explanation to see if you did it right, that might be helpful too.